take a look at finding coterminal angles. Coterminal means, terminal means to stop, so we want to find angles that stop at the same place as others. An example of a situation like this is when you have an angle like 540 degrees. I am hoping that you recognize 540 is over a full lap. If you were to get to the unit circle and go all the way around, we've talked about that that's 360 degrees. Well, if I go 540 is more than 360, but not a whole nother lap more, and sometimes you have multiple laps more, 2, 3 laps, whatever. But 540, we've got to figure out how much more is that. That's what we're looking at. Like, where would it stop so that it's also then coterminal with some other position on the unit circle that we look at. So 540 degrees we know is past a full lap, so literally all you do is you just take out 360. Because 360 is a full lap, I'm left with 180. So 540 is 180. It's coterminal with 180. It stops at the same place. So if I were to travel 540 degrees, it would be all the way around and that much more. So we say that these two angles right here are coterminal. So basically you're taking out the full laps by subtracting 360. Well, what if you have 120, which isn't even a full lap? Because 120, remember, here is 180, 150, 120 is right here just past the 90. So if I'm here, what is a coterminal angle that would also stop at 120? Well, wouldn't I just add 360 to put another lap on there? So if I add 360, I get up to 480. So 480 degrees would be a full lap and 120 more. These two stop at the same location. We call that coterminal. Negative coterminal angles also exist, where you can kind of unrotate, so to speak. If we travel this way in a positive rotation direction, we can leave home, which is right here, and travel in a negative rotation direction as well. So if I go negative 585, if I start here and travel negatively all the way around the circle, well, that's negative 360 because that's backwards. If I've gone negative 360, well, just, basically you can add that back on or you can subtract it from the absolute value of that quantity. You're going to get 225. So 225 and negative 585 are at the same location. So that's something we should be aware of. So if I just keep going, oh, by the way, that's negative because we had the negative number that we had here. So if I go negative 225, which is past 180, that's that halfway one right here. That's negative 225. That's a coterminal angle. Some people get a little bit weirded out by that. Well, how can you have a negative coterminal angle with another negative angle? Well, you can. These two stop at the same place. You could also go forward to get to that location also by finding a positive coterminal angle. We'll just add 360 to this. If you add 360 to it, right, then you're going to be, this is the negative, so this is 1. So basically you're doing 360 minus 225 in order to be able to pull that off. That's 135. So this location right here is also 135 degrees. So its positive coterminal angle is plus 135. Its negative is 225. The original was 585. All three of these stop at the same place, 135. Last one, negative 45. If I add 360 to negative 45, then I'm at 315. So what that means is if I travel negatively in 45 degrees, that's the same thing as traveling positive 315. Those two are your coterminal angles. If we were going to look at from radians, the radian situation is a little bit different. And on radians, if we have pi or 8 pi over 3, the key that we're going to talk about in class is doubling the denominator. We want to double the denominator and take out those full laps. This needs a little bit of explaining because if I were to start here and go all the way around, that is 2 pi, which is a full lap. Well, you need to be able to understand that what does that look like if I have a denominator of, let's say, 4. Well, if my denominator is 4, I double it, that's 8. So that's 8 pi over 4 would make a full lap. 8 divided by 4 is 2. That's 2 pi. That's what this reduces to. So we need to be thinking about double that number. So if I'm here with 8 pi over 3, then if I double my denominator, which would be 6, 6 pi over 3 would be a full lap because that reduces to 2 pi. 2 pi is the same as 6 pi over 3. So if I just subtract that off, I'm taking away a full lap. So then 8 from 6 is 2, so the answer would be 2 pi over 3 is coterminal. This is coterminal with 8 pi over 3. So those would be obviously at the same location. 2 pi over 3 is 2/3 to pi. This is pi over here because pi is 180, 2/3 of the way, so here's 1/3. 2/3 would be 120. So 120 degrees is that location, 2 pi over 3, and those are coterminal, and that's the location where I am. The other one, well, what if you started out with a negative? Well, if I double the denominator, that's 8. So if I added 8 pi over 4 to this, I would get to negative 7 pi over 4. That is coterminal. But some people want to get to a positive coterminal angle, so we add another 8 pi over 4, and that leaves just plain old pi over 4. So the key to this strategy is to double the denominator. So pi over 4 is coterminal with negative 15 pi over 4. Those two are a match. Here, what about 6? Well, double the denominator is 12. So if 25 is more than 12, so this is over a full lap. Heck, it's over 2 full laps. So if I take out 12 pi over 6, now I'm at 13 pi over 6. That's still past a full lap because it's more than double the denominator. Take out 12 pi again, and I'm at pi over 6 is coterminal with 25 pi over 6. Well, so is 13 pi over 6 technically. The last one, what about plain old pi? Well, pi is sitting right over here. There's a lot of ways to get coterminals with pi. I could do a negative pi lap. If I did, that's coterminal with negative pi. And then if I'm here, all I got to do is add 2 pi. So if I add 2 pi to it, that would be 3 pi. Any odd numbered pi is going to end up over here somewhere. 1 pi, 3 pi, 5 pi, and so on. Those are all going to end up over on this side of the unit circle. The even numbers are always going to be over here because 2 pi takes a full lap. So 2 pi, 4 pi, 6 pi, whatever, are all going to be over there.